scenario where we want to use our custom network subnet. By default, Docker container make use of default subnet, which is 172.17.0.0/16 for networking. There may be scenario in your network where you can't use this particular network subnet. Reason may be you got some restrictions or this particular subnet is already used. So how you can change it to custom? So in lab, we are going to modify the default subnet, which is 172.17.0.0/16 to, for example, 10.10.10.10/24. And the bridge interface is going to remain same, which is Docker 0 default. So first thing we have to do, we have to configure custom network. To do so, we have to stop Docker service first. Then we will bring down the Docker 0 interface, basically, which is a bridge. Then we will verify whether IP forwarding is enabled or not. If it is not enabled, then we are going to enable it in sysctl.conf. Why we need default IP forwarding? Reason, if we want to communicate with outside network, then we need IP forwarding to be enabled. Then this is the way to specify custom network subnet. Basically, the file is etc sysconfig/docker-network. So this is specific to Red Hat and CentOS 7. If you're using some different release like Ubuntu, you have to refer that documentation. For Ubuntu, the file is etc/default/network. And this is the Docker network options. We have to say bib this particular subnet. After that, we have to remove the default subnets masquerade rule from the post routing chain in network IP table. I'm going to use IP table command for this purpose. Once that is done, we can start our Docker service, and again we can verify whether masquerade rule have been new subnet added to post chain. So using IP table command, you can check that. And for validation, we can use command docker network inspect bridge. So as I mentioned, Docker 0, that is default network, and by default that's bridge. So that's a way to check what is the IP configuration. Other thing we can do, we can use docker inspect command. Again, I'm using -f to cut particular network IP address for that particular container. I have to specify container ID. Then another thing we can do, we can run a Docker container, and we can log into Docker container and see what is the IP configuration in that particular Docker container and whether that container can communicate with outer network or outer world or not. So that is going to be our quick validation. So let's begin our technical session, friends, where I can demonstrate this particular configuration to you. Okay, so this is my CentOS 7 server, and this server got Docker package installed. If you want to know how to install Docker package and what are the basic settings we have to do, you can refer my previous video. Okay, so first thing which I said, we have to stop our Docker service. Before that, I just want to show you the Docker interface configuration. If you see right now, it got default IP, which is 172.17.0.1/16. This is the default one. Another thing, let's check Docker network. So Docker network ls is the command to list out network interfaces. This is the bridge, which is default. This is the host one. This is for custom purposes. Let's check what is the configuration of this bridge interface as of now. So you can run command network. Sorry, that's Docker network inspect, then your interface name, that is bridge basically. If you see right now, this is the configuration inside this particular bridge interface. So we are going to modify it to 10.10.10.10/24. Okay, let's do our step. So first thing, as I mentioned, we have to stop Docker service. To stop Docker service, simply run systemctl, because this is Red Hat 7. Systemctl stop docker.service. If you go to Ubuntu or any other Linux, follow those commands. Okay, Docker service is stopped. Let me quickly verify whether service actually got stopped. Okay friends, we can see service is exited and it stopped. So next thing, let me bring down the interface. I'm bringing Docker 0 interface down, and let's check quickly whether it's actually down. Okay, if you see here, it is showing broadcast multicast, but up is not appearing. It means interface is down, state is down. That's another indication. Now let's change the default subnet configuration. As I mentioned in Red Hat 7, the file which we have to update, that is etc sysconfig docker network. Here this entry is blank by default. Here I'm going to append it, and I'm going to put my new network, basically that CIDR and the subnet. So that's 24. I'm using 10.10.10.10/24. You can use your custom one. So this is only for demo. I'm saving this file. So file is saved. Next thing, let me quickly show you what is the IP config rules at present before clearing the unwanted rules now. If you see at present, this chain post routing policy, the mask rate is 172.17.0.0, which is default IP. So what I'm going to do, I'm going to clear this particular rule because we don't need it now. We have already changed the IP address. To do so, I'm going to run IP tables -t, that's NAT, -f post routing. So it is cleared. Let me flush the Docker rule also, which is basically similar. Let's verify. If you see right now, there is no rule. So that's a good thing. And one thing, friends, I want to tell you, when we start our Docker service, new rule will be automatically created. So no need to manually create that rule. Okay, now let's start Docker service. Systemctl start docker.service, press enter. Okay, it started, so let's quickly check. Okay, service is running and enabled, that's good. So let's quickly check the IP address of our bridge, which is Docker 0. Okay friends, it got our new IP. If you see here, it got our new IP. So next thing we have to do, because interface state is still down, we have to bring it up manually, or we can simply bounce the network service, which is not desired for non-production setups. So let's bring this interface manually up. Okay, interface is up, and let's check Docker. Here it will always show down because that's a bridge. That's something no need to worry, because for this particular bridge we haven't used any physical NIC. It is communicating with the underlying network using IP forwarding. That's a reason, so don't get confused why it is still down. But here you have to verify this particular state itself. To make it more clear, if you see, this is the bridge Docker 0, this is the bridge ID, it's STP enabled no, and interface is nothing. So it means it does not have any underlying dedicated interface. It is using the underlying network, or you can say host network, using IP forwarding. So our configuration is done, and our new IP series, or you can say subnet, network subnet, is appearing. It means our configuration worked. That's good. So let's have one container running and validate whether this configuration is working. And what is the validation point? If from container we are able to connect with the internet, then I can say it is working. Before doing that, I just want to show you the new configuration of bridge. If you see now, this is the configuration, and gateway is appearing as same subnet. If you want to use any custom gateway, there is the option, like when you remember file where we have specified custom network, we can say -- gateway and our desired gateway. But I'm using the the same subnet as gateway, so I don't need gateway. But if you want, you can specify your custom gateway if you go to like VLAN kind of thing. So because this is my test setup, I'm not much bothered about that, but there is an option to add gateway. Okay, so let's run one container and validate what's its configuration. Let me quickly list out what are the images or Docker images I got on my system. So I got only one image which is sent to us, that's fine. So let me run a container using this particular image. So here I'm saying this is repo and run bash. So I will log into this particular container in this way. Okay, it's good. And if you see right now, prompt hostname is changed from Docker management to this particular ID. It means I am inside Docker. Let me run df -h. You can see you are not getting operating system data, so that's one validation. So let's quickly check if config or IP address. Oh, if config command is not there, IP command is not there, because in container by default you got very limited package space. That's a one reason, but no need to worry. For our validation we can use ping command. Let's ping Google. Okay, we are able to ping Google. That's fine. It means our network is up and we are able to do things. But let me quickly show you how you can install a package inside container. I'm going to use yum install. Let's install NetUtil.